Happy afternoon to all of you. Where yesterday we left, there only we are going to start today. Okay. Where we left yesterday, there only we are going to start today. So where yesterday we left, that certain element has a tendency to lose electron, either one or two or three. But a certain element has a tendency to gain electron, either one or two or three. And all their intention is to achieve the magic configuration of nearest inert gas. Because in inert gas, we observe either two electrons are present in the outermost or eight electrons are present. Especially if you talk about helium. Helium have only two electrons. Helium have only two electrons. That two electron is in the first cell only. The first cell accommodation capacity is 2. So that means that cell is completely filled, you can say. That means the element which has a completely filled orbit and orbital, they are more stable. Another point is like neon, argon. So they have what 8 electron in the outermost. That means they have a fulfilled orbital, you can say. So from this we can say that the element which is either duet configuration or octet configuration, they are more stable. So octet configuration in the valence cell. In the valence cell means the outermost cell. That's why your group 1A, all the alkali metal has a tendency to lose one electron, so positive valency plus 1. Group 2IA, alkaline earth metal, they have a tendency to lose two electrons because they have two electrons in the oil. Oil. Started, started, started. Kaveri. Okay. So, which is alkaline earth metal, they have two electrons in the outermost. So, that's why they can lose that one and they have a valency of plus 2. Group 3, that is called boron, right? So, boron family has a group valency is a plus 3 because they have a tendency to lose 3 electrons. Similarly, coming to the fourth one is carbon family. So, carbon family has a tendency not to lose, not to gain. So there another option will come that we call as a sharing option. Okay, but group valence is 4. Okay, coming to the fifth one. So in the fifth one, which is your nitrogen family. So there we find there are 5 electrons in that outermost. So there shortage of 3 electrons. So that's why they have a tendency to gain 3 electrons. That's why they got the valency as a minus. Similarly, the sixth A, which we call as a oxygen family, right? So they have 6 electrons in their outermost, so that's why they have a tendency to gain 2 electrons because there is shortage of 2 electrons for the octet configuration. That's why they gain 2 electrons and form negative valency or negative ion. Okay, seventh A. So that is called halogen family. That is a fluorine, chlorine, bromine, iodine are there, right? So here they have 7 electrons in their outermost, so there is shortage of 1 electron. So that's why your they gain 1 electron, right? And from the nearest inert gas quantity. All the intention of this element to achieve the nearest inert gas configuration to achieve the stability. Because the element in inert gas or zero group element, they are chemically inert, they are chemically stable because of their either duet configuration or octet configuration. Right. So rest of the element, they are unstable. Why? Now, because they don't have such combination, such configuration, either duet configuration like helium or octet configuration like neon and uh, your argon, right? That's why they're not stable. That's why everyone wants stability, either by losing electron or by gaining electron. This is suggested by your called G.N. Lewis and Kosel. G.N. Lewis and Kosel in 1916, which we call as electronic theory of valency. What is that theory called? Let me write here. This is called electronic theory of valency. And you know very well what is valency. Valency is nothing but the combining capacity of the atom. Combining capacity of the atom is called the valency. Means how many electrons they are losing or how many electrons they are gaining. They are gaining. So this we call as valency. That's this we call as electronic theory of valency, which was put forward by or proposed by G.N. Lewis, who gave the electronic dot structure EDS or LDS, suggested that there is no need of representing the useless electron which are not participating in the bond formation. So you should represent the electron which are participating in the bond formation or useful electron, that is nothing but valence electron. Jean Lewis and Kosel in 1916. So this theory we call as your electronic theory of valence. So from this we got some yesterday some question we read why the sodium chloride has a chemical formula as NaCl, why not NaCl2? So it is based on that. So if there is a combination between 1A and 7th A, 1A and 7th A, there will be a ratio of 1 is to 1. The chemical formula will be XY, like NaCl, KCl, all these. If this is going to combine with the sixth one, so sixth valence is -2, so it gains 2 electrons. So here we have only one. So sixth required 2 number of 1A. So that's a 2 times of 1A element combined with 1A or 1 ratio of 6A, and the ratio will be 2 is to 1. So chemical formula will be X to Y, right? Like our water molecule. Similarly, if you take a second, if you are talking about second, or if you are talking about the fifth, so fifth what will, now here it required, here it required 3. Here it required 3, but the 1A has only 1. That means fifth A group, it required 3 number of 1A group. 3 number of 1A group. So if there is a combination between 1A and third A, so what will happen? It required 3 times of your 3 times of 1A is required. Then the chemical formula will be what X, yeah. If you're taking this is the central atom, this is the central atom, this is your Y, and this is your X, this is your X, then it will be X your 3Y. It will be X3Y, or you can write it is a YX3, like NH3, like a NH3, ammonia. What is that? Ammonia. Here nitrogen, this is hydrogen. So NH3, right? Or we can write X3Y. Okay. Now similarly, if second A, so second A has a tendency to lose 2 electrons. So first it will find the 2 electron where it is there. So there will be an 1 is to 1 ratio, and it will form XY. That like NGO, CaO, so like that. If you take a second A and your seventh, so second has a tendency to lose 2 electrons, but seventh A has a tendency to gain 1 electron. That's why if there is a combination between second A and seventh A will be taken place, the ratio will be 1 is to 2. The chemical formula will be XY2, like MgCl2, CaCl2. So all this. Similarly, if I take your this your third, if I take the third, so third, how it will combine? Now there will be 1 is to 1 ratio here, 1 is to 1 ratio here, so it will form XY because both have similar capacity. So this has a tendency to lose 3 electrons, this has a tendency to gain your 3 electron. Okay. So if this will combine with this one, this will combine with this one. So here 3, here 1. That means 1 is to 3 ratio. The formula will be what? Now XY3, like AlCl3, aluminum chloride, aluminum chloride. So these are called electronic theory of valency, how the combination takes. So from this, you can understand that there is everyone. Okay, so every element they require either 8 electron in their outermost or 2 electron in their outermost. So from this, the rule prescribed, which we call as octet rule. What it is called? The octet rule. This is prescribed. So what is this octet rule? Now every element has a tendency. Every element has a tendency to achieve your octet configuration in their outermost shell in order to achieve stability either by losing electron or by gaining electron, either by losing electron or gaining electron. That's why this rule we call as octet rule. Okay, and somewhere we also call as a duet rule also. It is also called as a, it is not octet rule. This is duet rule, like in case of helium. Like in case of helium, that is called duet rule. And octet means 8. Duet means 2. So that's why the main rule is called the octet rule. So every element has a tendency to uh, attain the stability by or nearest inert gas configuration by either losing electron or by gaining electron according to their capacity. This theory or this rule we call as octet rule. So from this octet rule, from this your combination, a different type of combination came, which we call as a ionic bond formation. Right. So here we can say here this chemical rearrangement of the electron, which is holding the two atoms together, holding the two atoms together by means of electrostatic force of attraction, we call them as chemical bond. So a chemical bond is nothing but a linkage, or it is an electrostatic force of attraction which is holding the two atoms together. Holding the two atoms together. Later on, we are going to redefine the chemical bonding again. Right. So now the question is arising: how many type of bonds are present? How type how the bond is forming? How the bond is forming? So let us understand here how the bond is forming. What are the possibility? What are the possibility of the chemical bond to form between two atoms? To form between two atoms. Okay. So let us understand here. Okay. So what are the possibility? So suppose a student is a student is a, and another student is a B. Another student is B. So there are two students. A student has a two physical science textbook. What the A has a two physical science textbook. Whereas B has a no physical science textbook. No physical science textbook. Right. But both they want to read the textbook. Both they want to read the topic because the examination is coming out. So how they will read? What they will do? What are the options? What are the options? So your A has a two physical science textbook, whereas B has a no physical science textbook. So what are the various options are available so that both can read the content of the topic, both can read the lesson, both can prepare for the examination. So what are the alternative? Let us take one by one. The first alternative. What is the first alternative? The first alternative that A will A will donate. A will donate permanently. I'm talking again. A will donate permanently a textbook to B. So this is one option. This is permanent donation. Donate permanently. He will donate permanently. Right. Okay. Suppose he cannot donate. Suppose the mother or parent of A, student A, is saying that you don't give your textbook. Don't give. Okay. Don't give to anyone. You keep the textbook with you. So what is the another option? You can permanently donate that your textbook to your friend B so that he can study the same. If your parents are scolding, then what you will do? The second option you will go for the second option. What is the second option? The second option you will say you take this textbook for 7 days. You take the textbook for 7 days. After 7 days, you return back because my parents are going to scold me that I don't want a book. So this donation is not a permanent donation. This donation is not a permanent donation. We call it as a temporary donation. Temporary donation. So you can donate, right? You can donate that book to your friend B for some days. For what? Some days. So this permanent donation, this is suggested by your person. This is suggested by what? The person. So person suggested that your during the formation of the bond, certain element permanently donate the electron. Permanently donate the electron to other one, and other they accept that electron. Whereas your GND suggested that GND is suggested that way permanent donation is not possible. There is another option that is called temporary donation, which we call as sharing. We call as sharing of electron. Sharing of electron. So from this, we have two type of bonds. We have what the two types of bonds. So what are they? That chemical bonding are of mainly. I'm talking mainly are of two types. One is called the ionic bond. One is called the ionic bond, and the second one is called the covalent bond. Okay, of course, there are so many type of bond are going to learn in this lesson. Okay, so but mainly based on the how the electron are participating in the bond formation, the chemical bond are of two types. One is called ionic bond, or it is also called as electrovalent bond. Electrovalent bond. It is also called as electrostatic bond. Electrostatic bond. These are the three names, right? And the second type of bond we call as covalent bond. Covalent bond. So there are two options we got already. There are two options that either permanently you donate or temporarily you donate, or you can call it as a sharing. Right. That's right. There are two type of bonds are formed here. One is called the ionic bond or covalent bond. So this theory of forming the bond, we call it as a electronic theory of valency. Electronic theory of valency, which is proposed by Kossel and G. N. Lewis. Right. So what is this ionic bond? Now in ionic bond, what the permanent donation of electron takes place. So here permanent donation of electron takes place from someone has to donate. It is called the donor. It is called the donor. So who donates the electron? We call it as a donor. Okay. And who accepts the electron? Because chemical bond is a linkage. So there is a relation between two. So minimum two are required. So if one is donor, then other one will be accepting that. So we call it as a acceptor. We call it as a acceptor. So ionic bond is formed between, or ionic bond is formed due to the permanent donation of electron between donor and acceptor. Donor and acceptor. So Who can donate? Now, who has a tendency to lose electron? Who has a tendency to lose electron? That means, who can be a good donor? Now, either 1A element or second A element or third A element. This group element has a tendency to your lose electron. Alkali metal, alkaline earth metal, and boron family has a tendency to lose electron. Right? And all these are what? Now these are nothing but metals. These are nothing but metals. Similarly, who are the acceptor? Now who has a tendency to gain electron? Who has a tendency to gain electron? So what are they? Now you will come with the seventh A group, that is halogen family. Next sixth A group, that is oxygen family. And next is your nitrogen family, that is your fifth A group. So all these are halogen family, oxygen family, nitrogen family. All these are non-metals. All these are non-metals. So this is the prerequisite of formation of the ionic bond. This is the prerequisite of formation of the ionic bond. Right? Now one should be a donor, one should be an acceptor, one should be a metal, one should be a non-metal. Then only such kind of bond is going to form. Right? So how the ionic bond will form? Now if question will ask how the ionic bond is going to form or explain about the formation of ionic bond. So you will say ionic bond is formed due to the permanent donation of electron from the donor to the acceptor. The donor lose the electron, donate the electron to the acceptor, or acceptor gain the electron or accept the electron for the bond formation. And donor can be of either from alkali metal or alkaline earth metal or boron family, who are generally metals. Who are generally metals. And the acceptor can be either 7th A halogen family or oxygen family or nitrogen family. Right? They have a tendency to gain electron. So these all are non-metals. So that's why ionic bond is formed between a metal and non-metal. Metal and non-metal. So this is the primary requirement of formation of the ionic bond. So let us take the example here. So before I am going to your write the example, let me explain you that question may ask that how your MgO is formed, right? How K2O is formed, how NaCl is formed, right? How your CaCl2 is formed, how your KCl is formed, KCl is formed, like that. So many questions can ask. So everything we cannot disclose here. So that's why what I'm going to tell you here, I'm going to tell you about the mechanism. What I'm going to tell you, if you learn about the mechanism of formation of ionic bond, you can write all these things accordingly. Because according to this mechanism, I'm going to explain here. I'm going to explain here. Okay, so what is the mechanism? The point number one, fulfillment of primary requirement. Primary requirement. So this is the first point of mechanism, that the two elements should fulfill our primary requirement. Primary requirement, that one should be a metal, one should be a non-metal. Okay. Then the second point is a formation of formation of cation. So what is cation? That is a positive ion. Formation of cation and achieving the nearest inert gas configuration. Inert gas configuration. Inert gas configuration, either helium or neon or something. Right. Okay. Third point, here cation is formed. Next, formation of the formation of anion. Formation of anion. That means negative ion and achieving the nearest inert gas configuration. Inert gas configuration. Right. Then point number four. Point number four. That ESFA. What is this? The electrostatic force of attraction, because this is positive ion, this is negative ion. So when they are coming close, there is a strong force of attraction which is going to hold them together. This strong electrostatic force of attraction, this strong electrostatic force of attraction which is holding the two ions together. This we call as a chemical bond, and it is called ionic bond. So electrostatic force of attraction hold the two ions together, right, to form the molecule. Then the fifth is your structure. Then it will be over. So these 5 points compulsorily you should note it down, or remember that this is the mechanism, right? Whatever I am going to put in that order, I am going to put here. Okay, so let us take one of the example here. Let us take one of the example here according to this mechanism. So first point, formation of NaCl. First example, formation of sodium chloride. Sodium chloride. So first, how the sodium chloride is formed? The first point, Na reacts with chlorine forming NaCl. So what is Na? Now Na is a metal. Na is a metal, and Cl is a non-metal. So Na means non-metal, M means metal. That means the primary requirement is fulfilled. So as one of the element is a metal and another element is a non-metal, so between a metal and non-metal, the bond is going to form, that is nothing but called ionic bond. So you can justify your answer that yes, here an ionic bond is going to form. Why? Because one is metal, one is non-metal, which is the primary requirement of the ionic bond formation. Okay. Now, the second point. Your first, what is that? The sodium. So the atomic number is 11. So that's the electronic configuration. That is I can write directly neon configuration along with your 3s1 electron. So it has one electron in its outermost. It has one electron in its outermost. So that's why what will happen? Now this sodium will lose one electron. It will lose the one electron and it will form Na plus ion, which we call as a cation. So initial configuration is a 2, 8, 1. First cell consists of 2, second cell consists of 8, third cell consists of 1. So when one electron is lost, so it achieves the configuration of 2, 8. 2, 8, which is the nearest inert gas configuration of neon. Nearest inert gas configuration of neon. So stability is increasing. Stability is increasing. Okay. The next point is a formation of anion. So who is going to form the anion? The chlorine. The atomic number is 17. The electronic configuration is I can write here that your neon 3s2 and 3p5. 3p5. So it has a 7 electron in the outermost. That's why it gains only one electron. It has a tendency to gain one electron. So that's why chlorine will gain one electron and it will form Cl minus ion. Cl minus ion, which is our anion. So initial configuration of chlorine is a 2, 8, 7. So it is shortage of one electron. So when it gain one electron, the configuration becomes 2, 8, 8 now. So which is the nearest inert gas configuration of argon. So now chlorine minus ion is more stable than chlorine. Achieving the nearest inert gas configuration. Then what will happen here? Now this Na plus ion, it will come close to Cl minus ion, and between them there is a strong electrostatic force of attraction. So ESFA. So which is holding the two ions together. So it will form NaCl. It will form the NaCl. Now if you want to draw the structure, right? If you want to draw the structure, so how do you draw the structure? Now you can draw the structure like this. So one is here the sodium. So I'm drawing the structure here. Okay. This is your. Let me wipe out the top one. Right. Okay. So like the next point is your structure. Right. So sodium has how many you check? Three cells are there. So this is your sodium nucleus, first cell, second cell, and third cell. Okay. Next is your chlorine. It has also three cells are there. First cell, second cell, and the third cell. Right. Okay. So one is sodium. This is your sodium. This is your chlorine. So it has how many electrons we check here? First cell consists of 2 electrons. Second cell consists of 8 electrons. Third cell consists of 1 electron in case of sodium. Okay. Chlorine. First cell consists of 2. Second cell consists of 8. Next, third cell consists of 7. That is shortage of 1 electron. Shortage of 1 electron. So, what the sodium will do? It will donate this electron to chlorine. Donate this electron to chlorine. So then what will happen now? Now, your this become the same nucleus. Now, only two cells are left. Only two cells are left. Whereas chlorine has three cells now. Right. So, 1, 2, and 3 cells. Right. So, this entirety become electrically positive, and this entirety become electrically negative. Right. Which what is the configuration you observe here? These two, 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So one is achieving the nearest inert gas configuration of neon, and the second one is achieving the nearest inert gas configuration of argon. Now the two ions are held together by electrostatic force of attraction. So it will form. So what it will form? It will form your Na plus and Cl minus, form your NaCl. Form your water NaCl. See, I have just followed this. I have just followed this. Your 5 points. So that's it. Remember these 5 points. You can write any number of your example. Any number of example in the same manner. Just you have to change which element, what is the nearest inert gas configuration, what is the electronic configuration, how many electrons they are donating. Rest all are same. Rest all are same. Only the element will change, atomic number will change, electronic configuration will change, number of losing electron will change, structure will change. Rest all are same. Process is same. So remember this point. What? The mechanism of any formation of any ionic bond, the first point is fulfillment of the primary requirement. Means one should be a metal, one should be a non-metal. Second point, formation of cation by losing electron and achieving the nearest inert gas configuration. Third point, formation of anion by gaining electron and achieving the nearest inert gas configuration. Then two ions are going to be held by electrostatic force of attraction. Right. Then you are going to draw your water structure. So how the structure, how the dumping is taking place, you have to draw it. Right. So here you can observe here, Okay. We'll continue our discussion in our next because less than 1 minute left. If you have any confusion, you can ask. Again, some more